We're given a function and asked to integrate it and show that it's in this form. Okay, now of course you can use that to guide you, but just imagine for a moment, and it's worth practicing these, like we didn't have that guidance. Okay, and we're just asked to integrate this. Things that go through my mind would be, right, what about the derivative of the bottom? Is that equal to the top? Well, it's 2x. So if I rewrote it as x over x squared plus 9, I'd have that bit sorted. Now, do I know how to integrate 2 over x squared plus 9? And this is a classic integral that you should recognize. It is essentially the arctan integral. And of course, this will give you guidance in the question, but even if it wasn't there, you can get it. 1 over x squared plus 1 integrated is precisely arctan. This is just going to be something related to that, but it's actually going to be x over 3, and there's going to be a constant in there. This is where the formula book comes in useful in our case. So if you weren't given this in the formula book, what you would do is you would let x equal 3 tan u and then use the identities. But right here we can it's in the perfect form. Let's just rewrite it one more time, because that left-hand term's not quite in the right form yet. I want 2x here, so I'm going to make sure I get it, which means I need to halve my integral. Then it's still the same integral. With my other one, I'm going to bring the 2 out and then write it as 1 over 3 squared plus x squared. Okay, now it's perfect. So we get a half times ln x squared plus 9. If you differentiate that back, you would do 1 over x squared plus 9 times by the derivative of the inside, 2x, you get it back. And then this one here is going to be 2 times 1 over 3 arctan x over 3. So I'm just going to go straight away for the final answer and write it as 2 over 3 arctan x over 3. Don't forget your constant, and we're there. Show the mean value of f of x over the integral 0 to 3 is given by this. Well, if we want the mean, we've got some function. If we want the mean value of it, what we do is we make a rectangle. Maybe this here is 3. And we find the area of the original function, like the area under the graph between 0 and 3. Now they have the same base, so we just need to divide by that base, divide by 3, and that will give us the height, and that will be the mean value of our function. And we've got our result, so it's going to be 1 over 3, then in brackets, a half ln x squared plus 9 plus 2 over 3 arctan x over 3, and you were evaluating between 3 and 0. Okay, let's sub in 3. We're going to get a half ln 18 plus 2 over 3 arctan of 1. Then I'm going to minus a half ln 9. And then minus 2/3 arctan of 0, but actually that's just 0. This will become a third. I can bring the half ln 18 and minus a half ln 9 together, just factorize out the half, and then do ln 18 minus ln 9, that's 18 over 9, so I'm going to get a half ln 2. Hey, we've got our sixth ln 2 sorted. And then it'll be plus 2 over 3. Arctan of 1 is actually pi over 4. And I think we're there. 1/6 ln 2. A third, that becomes pi over 6 times a third pi over 18, or 1 over 18 pi as they've left it. So mean equals this, then this. And use your answer to part B to find the mean value over 0 to 3 again of this function. So we have taken the function and we've just added ln k to every single value. It's a translation. It's going to be like up here. And what's going to happen is the mean value is also going to be translated by that exact amount. If you think about finding the mean value of a group of people and then getting them to stand on a table that's 1 meter high, then, okay, the heights will be the same, but their heights now above the ground, all of their heights go up by 1, and therefore the mean height also goes up by 1. That's what's happening here with our function. So the mean, I mean, you could go ahead and do the same sort of integral. You could integrate the whole thing, divide by 1/3. We already have this result. So when you integrate a constant between 0 and 3, we're just going to end up timesing by 3. We're going to get 3 ln k, and then you divide by 3. You're going to show it that way, that the mean is just going to go up by ln k. But we don't even need to do that. The mean is just going to be 1/6 ln 2 plus 1/18 pi plus ln k. Now they want us to leave it in a very specific form. So to be able to combine the logs, I need to get a sixth, to have a sixth here. So what I can do is kind of times by a sixth and times by 6, but then bring the 6 up. Hey, they're the same thing. And then I can rewrite them all together. Not all of them, the lns together. So it will become 1/6 ln 2k to the 6 plus 1/18 pi. I haven't quite written it as p first, so all right, we'll do that. 1/18 pi plus a 6 ln. So that's my q, 2k to the 6. Good job.